In the name of Allah, the entirely merciful, the specially merciful. Dear third year students, this is our 9th lecture. Let's start. We will start by unsolved examples. Here, imports in billions of a specific sector of a certain country. There is two givens. The first one is the year from 2000 to 2010. Second is imports. Using moving average of 4 or of order 4, forecast the imports in years 2011 and 2012. We can find MA4 by of the year 2011 by adding these 4 imports of these 4 years from 2007 to 2010. We will add 10 plus 12 plus 10 plus 12 and we will divide them over 4. So the imports in 2010 will be the forecast of 2011 will be the summation of these 4 values over 4 and the result will be 11. Secondly, we want to find the forecast of 2012 by using the moving average of order 4. We will add 12 plus 10 plus 12 and plus 11 over 4. We use 11 because it is the forecast of 2011 and we will divide them over 4. The final result of the forecast of 2012 will be 11.25. Let's turn to the second example. This table represents monthly expenses for a student in year 2010. Months from January to December. It is for a 1 year. And expenses given. Forecast the students' expenses in the January and February, finally March to the year of 2011. Here, K will equal to 12, but in the previous example, K equal 4. So, the forecast of the January 2011 this year, we will add all of months over K, which is equal to 12. So we will add 2 plus 2 plus 3 plus 3 plus 4 plus 3 plus 4 plus 5 plus 5 plus 6 plus 5 plus 4 over 12. It will equal to 3.83. The second requirement will be the forecast of February 2011. It will equal to, we will add from 2, which is here is February 2011. We will add the demand of it, and we will drop the previous one, which is January, and we will add the forecast of January of 2011. So we will add all of these values plus 3.83, and we will divide them over 12. So the value of the forecast of February of the year of 2011 will be 3.99, and so on. We will add from 3 to 3.99 and divide them over 12. So the value of March of this year or 2011 will be 4.15. Let's turn to the third example. Here, the data represent quarterly sales in thousands. In year 2010 of a certain company, he gave to me 4 quarters, first, second, third, and fourth. He gave to me the sales of these 4 quarters, and he want to forecast the sales of the company in the first 2 quarters of the next year, which is 2011. Moving average for the quarterly data will be, for the first quarter, equal to the sum of all these quarters, or sum of these sales, over 4. The second quarter forecast will be 200, and in the lecture I said the second quarter will be 253. Okay, so we will add the second quarter plus the third plus the first and plus the first quarter in 2011. We will add 253 plus 408 plus 479 plus 374 over 4. Decomposition of time series. We understand how to decompose the series and estimate each component, and we know all of these steps. And we know that the multiplicative model is preferable than the additive one. And we know how to determine the trend. The determination of trend example will be as follows. This example gave me the data which represent the yearly sales of a company. He gave to me year from 1994 to 2003. He gave to me the sales of them. He wants to plot the time series data or sketch them. Number 2, he wants to obtain the moving average in order 3 and MA5. And he wanted to plot them over the original series. Firstly, we will plot the time series data by sketching them across 2 vertex or across two horizontal axis and vertical axis. And after obtaining MA3 and MA5, I'll plot MA3 over the original dataset or time series data, which I already plotted in the first requirement. Thirdly, use the half split averages to determine the trend. Fourth, obtain the trend or the regression equation using 1994 as a base year. Here, what is meant by a base year? We will put it second, please. We will put 1994 as a base year by putting it or converting all T or all years to, in 1994 we will put T equal to 0, 1995 will equal to 1, 1996 will equal to 2, and so on. You want to eliminate the trend component from the data. And 6, we will obtain the trend equation, but here we will use the mid 1998 as a base year, and we will obtain the forecasted value of sales in 2004. Here is the first one. In the first point, you want to upload the time series data. So I'll put years or time in the horizontal axis from 1994 to 2003, and sales I'll put it in the vertical axis. Okay, in 1994 and in 1995 the sales are 78. Okay, and so on. So I'll plot the data across those two axes. Okay. Secondly, he want to obtain MA3 and MA5. MA3 will equal to the sum of the first three sales from 1994 to 1996, and I'll divide them over 3. It's the moving average of these 3 years. Secondly, the moving average 3 at 1996 will be, I'll drop the first one, I'll drop the first one, and I'll add this observation. So I'll add 78 plus 80 plus 83 and I'll divide them over 3 and I'll put it in front of the year of 1996 and so on. In every observation or in every moving average in order of 3, I'll drop the last observation and I'll add the next observation and so on to reach to the final. Here I'll add 83 plus 82 plus 83 over 3 and I'll put the result here in front of 2002. But in moving average of 5, I'll add all of those 5 observations and I'll put the result in the midpoint. Midpoint here will be in front of 1996. It is the point which divide the observations to two equal sets. 2 lost and 2 coming. Okay? And so on. You want to find the linear or the trend equation. He gave me one hint that the base year is 1994. So when we put the 1994 as a base year, so it will be 0 and 1995 will be 1 and so on. Okay, to reach to 2003 it will be equal to 9. Sales is given, so the first step we will put the mean and find the mean of the year of years, which is 0 plus 1 plus 2 to reach to 9, and we will divide them over 10, the summation of x over n, and we will find the mean of years of sales. The second step, we will find t minus t bar. It is the third column here or the first column here, and in the next step we will draw a column of y minus y bar, y minus its mean, and we will find t minus t bar multiplied by y minus y bar. Finally, we will find t minus t bar squared. And the very important step is summing all of these values will be 44, and the sum of t minus t bar squared it will be 82.5. all of these steps to find B1. We know that y hat equal to B0 plus B1 multiplied by the t. So here the trend equation or the regression equation will be 78.81, which is equal to here plus 0.53, which we will find it here. But do you know the equation of B naught? Yes, of course. Let's write it. B naught equal to y bar minus y bar, which is equal to 81.2 minus B1, which we find it equal to 0.53 multiplied T bar, which is 4.5. Okay, so we find B naught, and nextly we find y hat. This is another way to solve this equation, and the equation will be equal to the last equation. We can eliminate the trend component by dividing yt over the forecasted one. The second example is, consider the following data, and he wants to plot the time series data, obtain MA3 and MA5, and he wanted to plot them on the original series, use the half split averages to determine the trend. 4. Obtain the trend or regression equation using 2001 as a base year, and obtain the forecasted value of sales in 2008. Eliminate the trend component from the data and obtain the trend equation using 2004 as a base year, and obtain the forecasted value sales in 2008. Firstly, we can plot the data in the easy way. Secondly, we can find MA3 by adding all of these observations, the first and second and third observation, and dividing them over 3. We will find the first moving average of 3, and so on. I'll explain it in the previous example. Here he put the 2001 as a base year. Okay, 2001 as a base year, so we put 2001 as 0, and so on. We put the production, it is a given. We add this column, which is T minus T bar and Y minus Y bar. We multiplied them with each other, and finally we find T minus T bar squared. It's a simple example. And we find the mean of Y and the mean of T. Finally, we find the B1 and B naught. But in the second example, when he bought 2004 as a base year, so we can draw it. He put here, sorry, it is a line. It is assumed to be a line. Here 2004 is a base year, so we will put it 0. 2005, it is the next year, so it will be 1. 2003, it is the previous year of the 2003, it is the previous year of the base year. It will be -1, and so on. We can find B0 and B1. So y hat equal to B0 plus B1t. So y hat will be 6 plus, it will be, so y hat, we can write here y hat equal to B0, which is equal to 6 plus 0.93 t. Determination of cyclical variation. But before we turn to this point, I want to concentrate on the previous example. This example, I forgot to explain this point when I said that 6 point obtain the trend equation using mid-1998 as a base year. Mid of 1980, sorry, here we will put this point as a base year. Here it is a mid here, it will equal to 0. So 1998 will be 0 minus half. Mid 1998 is a base year. 1998.5 is a base year. So we will subtract 0.5 from it to find the 1998, and we will add 0.5 to find the year which is will be in front of 1999. Okay, it's an important point. Forgive me for forgot this point. Let's turn to the exponential smoothing method. This method is important one because we will explain it again. The classification of the forecasting method discussed in the chapter divided into two distinct groups. The first one is averaging methods, which is centered moving average, simple moving average, weighted moving average, and so on. These methods conform to the traditional understanding of what an average is, namely, which is equally weighted observation. Have equally weighted observation. This is the averaging methods. But here, it is the second group of methods apply an equal set of weights to past data, and because the weights typically decay in an exponential way or exponential manner from the most recent to the most distant data point, the methods here are known as exponential smoothing methods. All methods of this second group require that certain parameters be defined. Certain parameters here will be alpha, for example, and these parameters value lies between 0 and 1. This parameter will determine the unequal weights to be applied to past data. The simplest exponential smoothing method is the single exponential smoothing method, for which just one parameter needs to be estimated. This parameter will be alpha, and it will be given in our examples or our exercises. So, the very important step here, or the conclusion of this slide, will be the exponential smoothing method apply an equal set of weights to past data. And the second important point that parameters of exponential smoothing method, or the smoothing constant, will lie between 0 and 1. The third important point here is weights will decay in an exponential manner from the most recent to the most distant data. Suppose we wish to forecast the next value of our time series yt, which is yet to be observed. Our forecast is denoted by ft, forecast of t at time t, when the observation yt becomes available. So, yt should be available. The forecast error, we know that from previous lectures, equal to yt minus ft. The method of single exponential forecasting takes the forecast for the previous period and adjusts it using the forecast error. That is, the forecast for the next period is next forecast equal to previous forecast plus alpha, which is the parameter or constant here, and it will be given in the exercise. Alpha multiplied by the error, which is the actual minus previous forecast. We will terminate this lecture at this point, and I'll explain in the next lectures. Thank you.